Well, if you guys can survive this last test, then you've made it. So congratulations. Maybe a little premature, but finally, Chapter 12, Test Review. This says sketch each angle in standard position. All that means is start here. Because of the negative, we go down approximately 55 degrees and classify each by quadrant. So that would end up in quadrant 4. 125, start here, we go 90, keep track, we have to go 35 more, which would be approximately there, we end up in quadrant 2. 415, remember a full revolution is 360, so we start here, we go a full revolution. If we think, okay, how much farther do we need to go? Well, that would be 55 more degrees, so maybe somewhere in there, quadrant 1. Negative 90, we start here. Negative just simply means go down, and that would be what's called a quadrantal, and because it's in between quadrants. Negative 675. This one's going to be a little tricky. So first of all, we got to start here, and because of the negative, go down. So there's 360. I'm just going to go like this to just figure out how much farther we need to go. So we need to go 315 more. Now, a little bit of math here. That's 45 degrees short of another full revolution. So I'm going to keep, remember, I went this way, and I need to keep going this way until we get 45 degrees short of another revolution, which would be right here, which would be quadrant 1. 750 means positive. So there's 360, there's 720. So we need to go 30 more degrees somewhere in here. That would be quadrant 1. So that's kind of an easy start for this test. Now they're going to make us actually do some trig. Don't forget SO, CA, TOA to get our basic sine, cosine, tangent. But then to figure out cosecant, secant, cotangent, we'll talk about that in a bit. First thing they want you to do is plot the point 5, 5. And these instructions, I'm just going to demonstrate what they want. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's a point. So what this instruction tells you is that you have a spinner and you spin it and it stops right there. And you're supposed to create your triangle by coming back to the x, never, ever, ever back to the y. So this would be 5, this would be 5, and this is, you can either go a squared plus b squared equals c squared and figure out what this hypotenuse is, or you can remember this is a 45, 45, 90, which I recommend. And if you know your geometry rules, you can just flat out say that's 5 square root of 2, and that's your hypotenuse. Now with it written like this is my opposite, this is my adjacent, this is my hypotenuse. Here's SO, CA, TOA. Sine would be opposite over hypotenuse, which we need to reduce that. 5 over 5 is 1 over 1. And then we got to get that square root out of there. So that'd be the square root of 2 over 2. Now, the reciprocal of sine is cosecant. The best place to take the reciprocal would be right here, which would be the square root of 2. Cosine would be adjacent over hypotenuse. So as you can see, it's the same thing as sine. So let's just cut the chase and say, hey, that's square root of 2 over 2. And the reciprocal of cosine is secant. And if this is the same as this, and this is the reciprocal of sine, then it will be the same for secant. Tangent is opposite over hypotenuse, which is 1. And if I flip 1, I get 1. That's it for 7. Number 8, we got to plot some different points. 1, 2, 3, 1, 2, 3, 4. Takes us right here, and that's where our spinner stops. Complete your triangle right here. So this is negative 3, this is negative 4. And if you remember from geometry class, you have a 3, 4, 5 family. Remember your hypotenuse can never be negative. So what is this would be my reference angle. I forgot to say that over here, that this is my reference angle. Hope you guys knew that because it's always sandwiched between the spinner and the x-axis. Same thing here. Here's my spinner. Here's my x-axis. That makes this my reference angle. Sine would be opposite over hypotenuse, and I can flip it, and that'd be negative 5/4 for cosecant, because those are reciprocals. Cosine would be adjacent over hypotenuse, flip it, I'd get negative 5/3. Tangent would be opposite over adjacent, which is just 4/3, and if I flip that, I get 3/4. Number 9, just a different point. Same process. I'm going to make the unit 1 huge, and then negative 1 make it huge so that my triangle can be large and I can see what's going on. So 1 to the right, 1 down would take me right here. Well, I can see if these two sides are the same, here it comes. There's a 45, 45, 90. And again, if this is x and this is x, this must be x squared root of 2. So I got to multiply that by the square root of 2. So that just gives me square root of 2. So sine of my reference angle, which in this case is right here because it's sandwiched between the x-axis and my spinner, would be opposite over hypotenuse. That's negative 1 over the square root of 2. Now, I like to take shortcuts. So right now would be a great idea to flip that. So it'd be negative square root of 2. But now I got to get the square root out of the bottom. Negative square root of 2 over 2. Cosine would be adjacent over hypotenuse. So that'd be 1 over the square root of 2. So if I flip that right now, that would give me a good, easy secant, square root of 2. Get the square root of 2 out of there, I get square root of 2 over 2. Tangent would be opposite over adjacent, so that'd be negative 1. And if you flip negative 1, you just get negative 1. So that's not too bad. Number 10, plot the point, negative 3, up 4. And that's where my spinner stops. So there's my spinner right there. Here's my reference angle. And this is just another 3, 4, 5 family. Sine of this angle would be opposite over hypotenuse. And if I flip that, that'd be 5/4. Cosine would be adjacent over hypotenuse. That's negative 3/5. Flip that, would be negative 5/3. Tangent is opposite over adjacent, so that'd be 4 over negative 3. Flip it, we'd get negative 3/4. There you go. I think those are the hardest ones. This one, for each angle, name its quadrant and its reference angle. Well, if we spin it, we go 126, which means 90 plus 36 is what is in here. But that would not be my reference angle. This would be. So there's a couple ways we could do this. We could go 180 minus 126, and that'd give us 54 for this. Or we could take this 36 and just subtract it from 90, and that's also 54. And that would be my reference angle. So that'd be quadrant 2, 54-degree reference angle. Negative 112 means go down 90, and then another 22. So that'd be negative 22 more, and then it stops. The question is that my reference angle? No. It's always sandwiched between my x-axis and my spinner, so I got to figure out what this is right here. Well, I'm just going to go 90 minus 22, which would be 68. So there's my reference angle, and I'm in the third quadrant. 659. Well, first of all, we know we're going to have to go around at least once, and then we would have 299 degrees more to go. So we'd go around, and then we'd have to go 90 plus 90 plus 90 is 270. So I'd have 29 degrees more to go. So that's my 29-degree chunk. But the question is this my reference angle? And the answer is no, because it's sandwiched between my y-axis and my spinner. I got to figure out what this is. Well, 90 minus 27 would be 61 degrees. So there's my reference angle, and that's quadrant 4. I didn't fill these in. That's quadrant 3. Okay, number 14. I need to go down. You can see 360, so I'm going to subtract it. So that'd be 1, that'd be 5, that'd be 2. I need to keep going 251 degrees. So I went all the way around. So if I went 90 plus 90, that's 180. See how much farther I need to go. That'd be 1, that'd be 7. I need to go 71 more degrees. So one more time, 360 is a full circle. And then if I went another 180, it'd take me here, and I'd need to go 71 degrees more, and then I stop. So this is 71. Now, is that my reference angle? Yes, because it's sandwiched between my x-axis and my spinner. So it's quadrant 3, 71. So they're going to throw some decimals at us for the grand finale here. Negative 344.2. Remember, this is a full circle is 360, so if I just subtract that from 360, I'm going to get 0.85, 15.8 degrees shy of 360. So that would be right in here, and that would be 15.8. So that'd be first quadrant and 15.8. All right, number 16 says write each of the following as a function of an acute angle. Acute means less than 90. Obviously that isn't. So if we took a look at that, we said, okay, let's spin our spinner 160 degrees. That'd be 90 plus 70 would be 160. But our reference angle right here is going to be 20. So I'm going to take that and I'm going to replace it with sine of 20 degrees. But if I make an imaginary triangle over here, sine is opposite, which is positive, over hypotenuse, which is positive. So if I said sine of 20, I could leave it like this. I don't need to insert a negative, because this with a positive would give me the same thing as this. So I've done it. So this says negative 106. So I got to take my spinner, spin it negative 90. I got to go 16 more degrees. Remember, that's negative 106. So if I go 180 minus that, I'd get 74. And that's what I would have right here. So that's technically my reference angle. That's what I'm going to replace the negative 106 with. So secant of 74. Now we're not done with these problems because we have to understand what is secant. Secant is the reciprocal of cosine. So we have to determine whether or not cosine is negative or positive in this quadrant. If we want to cheat, we could go all students take calc. Tangent's the only thing positive in the third quadrant. Therefore, cosine would be negative. Therefore, its reciprocal would be negative. And we would have to put a negative in there. And again, we could have used that over here too. All students take calc. Sine is positive in the second quadrant, and that's where this is. That's why this ended up being positive. So that's a different way of thinking of it. So here we go. We got cosecant of 117 degrees. So I'm just going to draw it right here. Start here. Spinner 90. And so we got 27.8 more degrees. Which, again, that is not my reference angle. But to figure out what's left, I could subtract all of this from 180. So that'd be 0.2, that'd be 2, that'd be 6. So this would be 62.2 degrees. First thing I do is change this to cosecant 62.2. Then I think, okay, what's the reciprocal of cosecant? Sine. So if sine is positive, cosecant will be positive. If sine is negative, cosecant will be negative. If I look up at this little chart, all students, sine is positive in the second quadrant. So if sine is positive, cosecant is positive, that means you can be done. All right, the last two problems, there's no way I'm going to finish it with the time remaining. I've only got about 30 seconds. So unfortunately, there's going to have to be part 2. We'll see you in 2 seconds.